Now we're going to do something similar, but it's going to be the mutable case. So I'm going to go down here, and we will. Well, maybe we should just close these out, just comment these out, and we will do the mutable part. This is mutable. The mutable, you have to use one of those string builders for the string buffer. Either one is fine. So we just use the string buffer. Change data, not address. Okay. So we have a string buffer. Remember, it's a class, and it's not imported automatically like the string. So you have to do that manually. And we'll just do again S1, put no string buffer. And then, oh, it does already. That's great. I think it did something to what I do. Okay, if it doesn't let you import, that's fine. I thought you had to. Alright, so we have S1, and let's do another one for S2. String S2, no string buffer. So now these are two memory objects that have different memory addresses in the heap. So they're not inside the constant pool. So if I say S1 append the word apple, just like we had before. Okay, we'll do the same thing with S2. Will be S2 to append Java. Okay, we can print them out. If I copy what I had earlier. If you just print them out this way, that's fine. You can just say S1, S2 just like before. You can also use the toString if you want to, but you don't have to. Okay, just S1, S2 will be fine. And again, expecting Apple and Java. Okay. And then the next one, we're going to say S2 equals S1, right? So they point to the same memory address. So S2 lost its memory address. So in other words, that object will be gone. If I print them out, you should see that both of them should have apple, apple. Just what we expect. And then now we're going to change S1. We're going to append a new string to it. Apple, I should say, is sweet. Put that phrase in there. So now the value is the apple is sweet. And then you print it out. So S1 would say is sweet. S2 will also say is sweet. Okay, and that is the distinction between mutable and immutable objects. Here I'm changing S1's data, but it also at the same time affects S2's data, because here, line 33, I assign S2 pointer to S1, so they point to the same memory address in the heap. And then once I change the value of either one, okay, it affects both of them. If you have a third S3 that points to the same S2, then all those will be changed. And this is why it's useful. It also can be dangerous because you may be using the same a different value to do some type of calculation, and you expect that to be true, but then it's no longer true because somebody else actually modified the value of that S1. That affects S2 as well. So if you run this, you will see that exactly what we have in mind, right? So they're both different. They're both equal because we assigned them to in line 33. And then line 37, I changed the value of S1 only. I did not touch S2 at all. But you can see that it actually affects S2 as well. Okay. And because they're pointing to the same memory address.